Today's video is on integration using residues. In today's video, we are going to find the poles of the residues of the function f of z is equal to 3z plus 1 by z plus 1 into 2z minus 1. So how we have to find the poles? So in order to find the poles, we have to equate this denominator to 0. First of all, our function f of z is given as 3z plus 1 by this is z plus 1 into this value is 2z minus 1. So in order to find the poles of the given function, we have to equate the denominator to 0. So here the denominator value is z plus 1 into 2z minus 1 is equal to 0. So if I equate this z plus 1 to 0, here our z value will be minus 1, which is a simple pole. So this is a simple pole. And here 2z minus 1, if I equate this to 0, our 2z value is equal to 1 and z value is equal to half, which is again a simple pole. So this is again a simple pole. Now we have to find the residues. So how we have to find the residues for the given function? Poles, in order to find the poles, we have to equate the denominator to 0 and we got two poles. As the first pole here is z is equal to minus 1 and the second pole here is z is equal to half. Now we have to find the residues for these poles. So first of all, we have to find the residue for the simple pole z is equal to minus 1. So residue of the function f of z at pole z is equal to z naught is nothing but limit z tends to z naught, limit z tends to z naught, this is z minus z naught into f of z. Now in order to get the pole value, we have to equate the denominator to 0 and at the pole z is equal to minus 1, here this will be minus of, here z naught value is minus 1, minus of minus plus 1 into f of z. So what is our f of z value? So f of z value is nothing but 3z plus 1 I am writing, that is f of z value is nothing but this value is 3z plus 1 into z plus 1 into 2z minus 1. After substituting the f of z value as 3z plus 1 by z plus 1 into 2z minus 1, so I am cancelling this numerator and denominator, and in the remaining value I am substituting z value as minus 1. So here if I put z is equal to minus 1 and see here, this will be 2 times of, here there is z, I am substituting minus 1 and this is minus 1. So here this will be minus 3 plus 1 by, this is minus 2 minus 1 and this is minus 2 by minus 3, the value here is 2 by 3. So this is the residue of, this is the value of the function at z is equal to, see here z is equal to minus 1. At the pole value z is equal to minus 1, we got the residue value as 2 by 3. Clear? So this is how we have to find the residue values for the simple poles. For simple poles, the formula here is z, limit z tends to z naught, z minus z naught into f of z. So here our z naught value is minus 1 and f of z value is from this function 3z plus 1 by z plus 1 into 2z minus 2. And after cancelling numerator and denominator and substituting z value as minus 1, we got the residue value as 2 by 3. And the next one here, the simple pole is half. So for finding the residue for half, this is also for residue value of the function. So residue of f of z at point z is equal to z naught. Here for simple pole, limit z tends to z naught, this is z minus z naught into f of z is the value. For z is equal to half, z naught value, if I keep this as half and see residue of the function, see here residue of the function f of z at value z naught is equal to half, this will be limit z tends to z naught value is half and this is z minus half into f of z. So what is our f of z value? So f of z value is this one as 3z. So this is 3z plus 1 by this value is z plus 1 into this value is 2z minus 1. And how to cancel this one? So in order to cancel this one, I am writing this as limit z tends to this value is half. This is z minus half into this value is 3z plus 1 and this is z plus 1. So if I take 2 common, this will be z minus half. So now I can cancel this numerator and denominator and substitute z value as half. So this is 3 into half plus 1 by, this is 2 into z value is half. This is half plus 1. So this will be 3 by 2 plus 1 by, this is 2 times of, this is 1 plus 2 by 2. And if I take 2 as LCM, this will be 3 plus 2 by 2 times of, this is 1 plus 2 by 2. So if I cancel this one, 2, this will be 5 by, so this is 3 plus 2, this is 5, and this is 2 into 3. So the value here is 5 by 6. Therefore, the residue of the function f of z at the pole value z is equal to half is nothing but 5 by 6. So this is the residue value for the corresponding pole z is equal to half. See, this is also so simple. What I have done, see, f of z is equal to 3z plus 1 by z plus 1 into 2z minus 1. So here we have to find the poles and the residues of the function 3z plus 1 by z plus 1 into 2z minus 1. So in order to find the poles, we have to equate the denominator to 0, and after equating z plus 1 to 0, we got z is equal to minus 1 is a simple pole, and z is equal to plus half is also a simple pole. So for simple poles, the formula is limit z tends to z naught, z minus z naught into f of z. Here's our z naught value is minus 1, and after substituting minus 1 here and cancelling z plus 1 in the numerator and denominator, and substituting minus 1 in the rest of the function, so here z value as minus 1, so this is 2 by 3, and the next value here is z is equal to plus half. So after substituting z is equal to plus half in the place of z naught as plus half, and the function value is here. And how to cancel this one? After taking 2 as common, this will be z minus half, and after cancelling numerator and denominator and substituting z value as plus half, we got the residue value as 5 by 6. This is how we have to solve. This is so simple, most important question. So please practice and pass it on to your friends. Thank you for staying till the end.